I want to say that I, I've noticed. I think a few people might have gotten themselves a little behind, not paying attention to the grade book. Even though I had said multiple times I was pushing grades into Q4, I kind of think some people had gotten themselves a little behind on that. So you really need to make sure you're looking into your grade book today, seeing where you're standing on um, your grades so far in quarter four. Again, the reason I did the grading the way I did and when I started them where I did was so that if we had things that we needed to correct, redo, and so forth, we had time to do that. And then also because one of the weeks towards the end of the year is SC ready testing. Um, we have another day of map testing, and then we'll be wrapping up the last couple of days. So there's really less time to grade in the fourth 9 weeks anyway. And that's always the case no matter what kind of school you're in. So just kind of doing it that way gets us going on our fourth quarter grades. All right. So again, we get logged in here. We're about to get moving on our lesson for today. All right. Now we are doing map testing on the 25th. So not next week, but the next week on Monday. And it's gonna be really important that we show improvement on that. I think is really super important. And so we'll come in during our live lesson time. And we have to use that for that one, which means it knocks out another live lesson for me. In terms of like time I have with you. So what we're gonna be doing today is one of the data and statistics standards, and then tomorrow you're going to work on review of one standard from earlier in the year. Okay, so this stuff you know all that. Again, we got two quizzes already in the grade book. And what I decided was you probably were expecting, based on what I'd said before, that I was going to do a unit test at the end of this week. I decided that I would count those as majors and that we would just go ahead and move with those because I felt like those were I think I had good assessments written there. And so I think we're gonna move forward. If you got stuff that you didn't do well on, I would love to work with you, talk with you about what to do to redo those things and to improve on that. Okay. Um, and then there was lift off legends of or legends of learning, depending on what you had um last week. Okay. I don't have any of that for this week because we have a short week. Okay. Um, okay, so you should be logged in by now. Be getting logged in to our Nearpod. All right, so here's what we're gonna do today. Today we're gonna one day knock out this standard, differentiating between statistical and non-statistical questions. So those of y'all who don't like showing work in math, today's your day. Okay, so today is one day where you're not gonna have to show work. All right, it's just kind of thinking through some things. Um, and then tomorrow we're going to review the GCF and LCM standard. Okay, I got some videos posted that will help you out with that. Then some practice, and I want that shown. So tomorrow's work does have to be shown and shown in a certain way. And then we're going to do a quiz on Friday over this little standard right here and reviewing this one right here from earlier in the year. You're like, I wasn't here earlier in the year. Okay, fine. That's why we're doing it again. Okay, so we're taking a whole nother day doing that tomorrow with some videos to help you out with that. Okay. All right. So today we're going to talk about statistical questions and non-statistical questions and explain the difference and then what it means when data has variability. You're like, what the heck is that? I'm about to tell you. All right. So first of all, let's look at dot plots. Okay. Some of y'all are still not logged in. You need to get logged in. You know, you're not doing what we're doing, then that shows on your grades. Okay. So dot plots are ways to represent data on a number line. So each time a value appears in the data set, um, Basically, you put a dot. Okay, and this one is more like a maybe fourth grade. You learned this the first time. So in this dot plot, there are three dots above the number 9. So that means there were three different plants that had a height of 9 centimeters. On the 10, there's 5 dots. That means 5 plants had a height of 10 centimeters. There's only one at 7, so one plant had that height. And there's none at 5. That means that no plants had that particular height. Okay. So you're listing the value for each piece of data as a separate dot there. Okay. Okay. So first one we got here for you to do is all right. So we got a dot plot for a data set. And so what we're looking at here is first determine if this would be an appropriate label to represent the data in the dot plot, and then be prepared to explain your reasoning. So for each one of these, just put yes or no. So like just put Y or N next to each one of them right here. Okay. All right. So number of children in a class, 0. That looks like half. So that's like 1/4, 1/2, 3/4. So there's like 2 and 1. All right. And then B is distance between home and school in miles for certain people. Does that make sense of this data plot? Hours spent watching TV each day. Yes or no? Does that make sense of this? Weight of elephants in pounds. Yes or no? And then points received on a homework assignment. Yes or no? Okay. So just put the, all right. So just put Y or N next to each one of these. So on the first one, I'll go ahead and show you the first one. Does it make sense for a number of children per class to be 0, 1/4, 1/2, 1/2, then 3 at 3/4, and 2 at 1? No, absolutely. That doesn't make any sense because you're not going to have a class with 3/4 of a child in it. That doesn't make any sense. Okay. So go ahead and fill out number 1 here. Give you a few seconds on that. You just got to put Y or N next to this. Okay. Not super complicated. So just yes or no on the first one here. Do these make sense? Okay, so the second one, distance between home and school in miles. So could you have somebody who lives like literally right next to school, and that would be 0, and somebody else who lives a fourth of a mile from school, somebody else is half mile from school, right? Somebody lives 2.5 miles from school. That is possible. Yes. So I would say yes on that one. Okay. Hours spent watching TV each day. Somebody watched no TV, somebody watched 15 minutes, do you watch 30 minutes, and so forth. Yeah, that absolutely could be this dot plot. Weights of elephants in pounds. No, unless you're talking about like stuffed animals, right? And then even so, you couldn't have a stuffed animal elephant that weighs 0 pounds. So that doesn't make sense anyway. And then finally, points received on a homework assignment. So unless it's out of 2.5 points, that doesn't make any sense, right? So I would say no on that one. Okay. All right. Any questions on that first one here? All right. Next one, we have think of another label that could be used with the dot plot. So write it below the scale of the dot plot, meaning write your answer right here, right here. Okay. So be sure to include the unit of measurement in your scenario. What does one dot represent? What would the data point 0 mean? And what would a data point of 3 and 1/4 mean? Okay, so I want you to go ahead and write down, okay, what another appropriate scale would be on this. Okay. And then kind of put what each dot represents and what a data point of 0 means in 3 and 1/4. Okay, I'll give you about a minute to do that. So you just need to, for part A, you just need to write like the label, which could be written like right underneath the other one. You don't have to come up with a whole nother dot plot. You don't have to come up with another dot plot. Some of y'all are trying to come up with a whole nother one. I don't need that. All you got to do here is write your example, right? So write your answer for A just right here. Don't rewrite a whole nother dot plot. So Liam, all we're doing right here is we're just using dot plots. Okay, this is not super hard. All we're doing is seeing, so like on this one, for example, hours spent watching TV each day. This would make sense here because that means that somebody didn't watch any TV, somebody watched 15 minutes, two people watched an hour, one person watched 2 hours. That doesn't make sense for the weight of elephants because elephants all weigh more than 1 or 2 pounds. Okay. So what we're saying here is what is another way that this dot plot could be accurate for another situation? All right. Let me see what situations people got here. Time it takes to do something. Somebody's coming up with that. That would make sense. Time outside. That would work. Yeah. A person who spent blank hours at the something. That would work too. All right. So anything like hours spent doing something, that would make sense. Okay. I was thinking, so the example I thought of would be um miles run by athlete, right? That's my example. Okay. So in this case, we're at a like a track practice, right? So each dot represents one runner in my example. Okay. And in my scenario, the data point 0 would be somebody who was injured, so they didn't run, right? A data point of 3 1/4 would be they ran 3 1/4 miles. Okay. So that would be a good example of that. All right. So go ahead and finish up with your example there. Just a minute to finish that up. They spent. All right. So somebody bet hours learning the ABCs, which is fine. You know, one dot represents. So each dot would represent either each person learning the ABCs or each occasion that they, each time that they were learning the ABCs, how long they did it. Okay. Um, so you'd kind of want to change the B on that one. Okay. Let's see. Minutes from the store. Okay. So you would just want to, on this one right here, you just want to use the same example for A, B, and C. So if it's minutes from store, each dot represents like a person um, in that case. Okay. And then 0 minutes would be somebody who lives like right next door to the store. Okay. Anybody else want me to look at theirs before we move on there? Okay. All right. I'm moving on in 5, 4, 3, 2, and 1. Ah, there we go. All right. So next thing I want to look at, and that was just kind of a first example on reading dot plots, which is actually an earlier grade, but you're going to need to be able to do it for some of the stuff in sixth grade. Okay. So um the next thing we need to look at is categorical and numerical data. Okay, which sounds like big words, but it's really not that hard because categorical means related to categories. Okay, so related to categories, a set of categorical data has values that are words instead of numbers. Okay, so if you ask people their favorite color and they said blue, blue, green, blue, orange, then in that particular case, That's categorical because it's different like types of things. Okay. If I ask people who their favorite college football team was, that's categorical because then you would get answers like South Carolina, Clemson, and Georgia, right? And so those would be categorical type answers. Okay. Now, numerical data is ones that are answered with numbers, right? Numerical. So the ages of people in his family 7, 10, 12, 36, 40, 67. Or things like, okay, how many dogs people have in the class, right? So that would be a numerical set of data. If I ask what types of dogs people had, and I put them in different families of dogs, like types, categories of dogs, like retrievers, right? And different things like that. Okay. Um, so that could potentially be if you use it that way. Okay. So all we're looking at here is whether or not something is numerical or categorical data. Okay, so here, all right, so we have these survey questions, and we want to know, do they produce numerical data? So you can put an N for numerical or C for categorical. So just put it either an N or a C beside each one, like right here. Okay, so put an N or a C next to each one. That's all I was asking you to do. So it's not super hard. So you would answer, if it's answered with numbers, okay, then you put an N. If it's answered with a category or a type of thing, you put a C. Okay, give you about 30 seconds on that. Okay, you should be about done at this point on this one. It's pretty quick. Okay, so let's go over this. How many pets do you have? Okay, well, if you think about it, would you answer that with a number or a type of thing? No, you would say a number. I have one pet. I have two pets. I have no pets, right? So that's numerical data. You answer with a number. How many years have you lived in the state? 0, 1, 2, 3, 4, 5, etc. That's numerical. What is your favorite band? That's categorical, all right? Because you would say a name of a thing as opposed to how many bands do you like? That would be numerical. What kind of music do you like best? That's categorical. What is the area code? That's a number of your school's phone number, right? So that's numerical. Where were you born? That's categorical, right? If we ask what your birthday was, that's numerical. How much does your backpack weigh? That's a number, numerical. If it was, what type of backpack do you have? That would be categorical. Okay. Any questions on that? I think it's pretty straightforward. Right. So I did put one of those, each of these things we've done so far on the practice tonight, I think. Okay. Okay. One more page of these. Okay. So pretty simple stuff. All right. So go ahead and write C or N again. All right. Is this categorical or numerical? C or N. Okay. About 10 more seconds. Okay. First one, your favorite vegetable. That would be things like, um, you know, zucchini or cabbage or something like that. So that's a category of things. Have you been to the capital city of your state? Yes or no. So that's still categories. Right? How old is the youngest person in your family? That's a number. Your zip code, which you should have memorized, that's a number. The first letter of your name is categorical because we would have different letters. And then how many hours you spend outdoors each day, that's a number, numerical. Okay. All right. Yeah, Lorraine, this lesson is pretty easy, right? And that's why, so there's some parts of this standard that will show up on, might show up on your map test or SC ready. And I'm like, dude, we're going to get to that because I'm not going to have you miss like the easiest standard, right? So I was thinking this one would go well with reviewing one from earlier in the year. That's kind of how I had planned this with this really short week. Okay. Um, Now let's look at this. This is kind of thinking of an appropriate set of data. This actually kind of overlaps in another data standard here. All right, so we have some data in centimeters. So that's a length, right? So if we're talking about centimeters, meters, inches, feet, yards, miles, those are all lengths of things. Okay. If you have kilograms, grams, pounds, tons, those are all weights or mass, right? So if we have a data measurement of 8.5 centimeters, 10.5 centimeters, 7.8, and so on, which of these could he be investigating, studying? So you need to circle any of these that would make sense of this data set. Pay attention to this is a length. Okay. So you got to be thinking about what you're measuring. Are you measuring length? Are you measuring weight? Are you measuring time? Right? Are you measuring speed? Okay. So I see one right answer, maybe two, definitely two, maybe three. Okay. All right. Give you a few more seconds here. So just circle the right answers. There's definitely two. I think there's probably three. Okay, so make your picks. See if you're right here. The key is this is length. Okay, so immediately you should say, nope, it's not the weight of a dozen eggs. That's a no. Okay, it's also not the length of songs. You can't measure length of songs in centimeters, right? You measure those in length and time. Okay, so those are definitely wrong. Now, 9 centimeters is like 5 inches. Okay. So that would be definitely appropriate for length of leaves from a tree, as well as length of colored pencils in a box. Um, Height of cups and mugs in a cupboard, I would say yeah too. All right. Y'all can tell me if you think I'm wrong on that. But it's definitely not A and D. A and D are definitely wrong. Okay. So I want you to see that just to recognize that it does say length, but it's talking about length and time. Okay. I think B, C, and E are the ones that make sense too. All right. Anybody got any questions on those? Okay. So again, another part of our data standards is matching like what sort of this data fits this explanation, right? That's another thing we have to do. Okay. Okay. Now, this is the one that I kind of do need to define for you today. Okay. And I don't think this is hard. Okay. But here's what we got to look at. So we have statistical questions and we have non-statistical questions. So non meaning not. So these three are statistical questions. What is the most common color of cars in a certain school parking lot? What percentages of students in the school have a cell phone? What kind of literature, fiction or nonfiction, is more popular for students in the school? And then these three are not statistical questions. What color is the principal's car, or like your mom's car? Right? Does Elena have a cell phone? What kind of literature does Diego prefer? Okay, so what we're looking at here is what is different about these questions? Who's got an answer that they got any volunteers that will share that? Okay. All right, let me get back on where did my little picture of where are people at? I don't see. 1 second. It made people disappear. Where are you people? Um, Hold on 1 second. Trying to find you. All right. Lorraine, what you got? What do you think?
So, the statistical questions, like if you ask like 10 people those questions, all 10 people are gonna have the same,
They're gonna
but
have what?
with they're gonna have the same answer.
On the
It's the statistical,
non-statistical question?
no, the statistical
So well, okay. I think some of these questions are not necessarily as clear as I think they ought to be. But what so the deal is if we're trying to figure out the most common color of cars in the school parking lot, what we'll actually have to do here is that we'll have to go through the parking lot. And are there different colors of cars in a parking lot? Yeah. All right. And then if we go and see, do this the students have a cell phone or not, then we're gonna have, okay, yes, some of them do, some of them don't, right? Then, which one is more popular? Then you would say, do you like this or this, right? So there's all these different answers. Great. All right, Gray, what are you thinking here?
I thought that like what the color is the principal's car, that's gonna be a straightforward answer.
Mm-hmm.
And you don't have to like every single person and every single test you do to figure it out is always gonna be the same,
Mm-hmm.
as long as they don't get a new car.
Right.
And like
So
what
so
is the
right
most
now
common?
there is one answer. If this is, say, the principal is Miss Snyder, okay? What color her car is like there's a certain right answer to that, right? Um, this certain person named Ella, either she has a cell phone or she does not. Right? That is a factual question. And then Diego, this one person named Diego, he either has this preference or he does not, right? So, but if we go to say 100 different cars, there's going to be a bunch of different colors. Now, there is a right answer to this one, but see that the data we collect is going to depend, right, on, okay, well, we got this many of these, this many of these, this many of these. So there's variation in the answer here, okay? And that's going to be kind of the key to this is a statistical question can be answered by collecting data that has variability. Okay, so here's the key. It varies. It depends, right? So some examples of statistical questions. How many minutes do sixth grade students spend on homework each week? Okay, so don't be confused if it says like on average, right? Or something like that. Because what you do, if it says on average or what is typical, or right, what is the, I don't know, you would be gathering all these sixth graders' minutes, right? And then you would be analyzing those things. Um, so that would be a statistical question. If we said, um, how many minutes does Chloe spend on homework each week? That would be not a statistical question because there's just that one answer. Okay. What is typical bedtime of a seventh grade student? So you would have some people it's 8 o'clock, 9 o'clock, 10 o'clock, and you have these different categories of your data. Okay. So that's varying. It depends, right? The answer can depend. It's not just one possible answer. Okay. So to have variability means having different values of the responses. So, like on this data set right here, both of these have variability, okay? Because it's not all the same answer. But you see, this one right here has a lot more at 40 than some at 39, 38, 42, 43. But it doesn't vary a whole lot, right? It's all in this little area. Whereas this data set varies a lot more because it's all spread out. So you would say this one has greater variability than does this one, okay? So it means it varies or it changes more from, you know, response to response, right? So there's a lot more difference between them. Okay. Okay. So well, let's look at each one of these little questions here. Okay. So it says read each question, think about the data you might collect to answer it, and whether you expect to see variability in the data, like will it depend? Complete each blank with yes or no. So you need to be writing yes or no in each one. All right. So first question, how many cups of water do your classmates drink each day? Okay. So would you expect variability in the data? Like, do different people drink different amounts of water? Okay. And then is the question statistical? So go ahead and write your first one here. Is that yes or no? Do you expect the data to vary if I ask everybody how many cups of water they drink? So therefore, is the question statistical? So go ahead and put what you think. This is the kind of the key to the whole thing here, right? And this is the reason I like this particular set of questions. Okay. The answer is yes. Not everybody drinks the same amount of water in a day. So since the answer would depend on the person, then we would say the question is statistical. So that's a yes. Okay. Where in town does the math teacher live? Okay. So I will let you know that I'm not super rich, so I don't got a bunch of houses, right? So I got one house and I live in that house. That house is at a certain place. Okay. So if you came to Powdersville, all of you would find that I live in the exact same place. Okay. I don't live in different places. So is there variability expected in the data? Hopefully you put no. I live in one place. Is the question statistical? No, there's no variation in the response. Okay. All right. Then the third one, go ahead and do the third one. So somebody put on B, B is no and no. Okay. There's no variability on B. So therefore it is not statistical. Okay. Yeah. So fix that if you were wrong on that. So one, the A is yes, yes, B is no, no. Hopefully you're recognizing that the answer to these two, the questions in the pair should be either both no or both yes. That's the idea. Okay. How many minutes does it take students in the class to get ready for school in the morning? If I ask all of you that question, some of you would say 5. Some of you would say 30. Some of you would say an hour. So does the answer vary depend on the student? Yes. Therefore, is the question statistical? Yes. Okay. Any questions on that? Hopefully that's making sense. If you say the answer will vary depending on, you know, who your person that you're sampling or whatever thing you're sampling, then in that case, that's a statistical question. That's all there is to it. Okay. Questions on that? Okay. All righty. Next, close that up. All right. So Lynn and her friends went out for ice cream after school. The following questions came up during their trip. Select all the questions that are statistical. So circle the letters of the ones that are statistical. Now, I put a note on here. This is my note for you. I think a couple of these examples here are kind of unclear. The ones I put on a quiz on Friday are more clear than these as to whether they're statistical or not. Okay. So you're circling right here the ones that you think are statistical questions. Okay. And then I'll talk through why I think they are what they are. So if they're going to one certain ice cream shop, all right, they're going to just to this one ice cream shop. So there should be one that you should immediately eliminate, I think. Okay, I think the one person that put this one in, they're thinking about getting rid of it. Nope. Okay, So the one that you should get rid of, which most of you have not picked, is E is wrong. That's not statistical. If you go to this ice cream shop, right, and you say, how many toppings do you have to choose from? They would say whatever the answer is, but that answer is not going to change if you ask them again in 5 minutes or you ask a different worker because they have that set amount of things that you can choose from. That's not changing, right? Like that's on one day when that is asked. That is a set number. It does not vary. Okay. All right. Now, so the reason I think this is kind of confusing here is that B, I think, is statistical data because it could be like this many people picked strawberry, this many people picked chocolate, this many people picked vanilla, and so forth, right? So when you say the most popular, you're like, but that's one answer, right? If you go ask the people at the store what was most popular this week, then they have all the data already collected. They know that would be different. But if you think about it like this, that 7 people got vanilla and 5 people got chocolate and 4 people got strawberry, then would that be statistical? I mean, yeah. Okay. So I would lean towards that being statistical. All right, that's the reason I said that was kind of confusing. How far are we from the ice cream shop? That is I think, a factual question where it doesn't vary. Like if you look up at a particular time, how far are we from the ice cream shop? We're 7/10 of a mile. Okay. Just because you go ask again later doesn't really make it a statistical question. It's the facts are you are a certain distance from the ice cream shop. Okay. What does a group of 4 people typically spend on ice cream at the shop? That's statistical for sure because you got this group that spent $23. This group spent $18. This group spent $20. So you get varying answers. The kids usually prefer to get a cup or cone. Again, I think this one's kind of confusing, but I would say yes because you got two possible answers, right? Cup or cone, right? So you got two different things. It varies depending on the kid. Then you can see which one is more or less after you gather all the data, but you're comparing two sets of data there. So therefore, it is a statistical question. Okay. All right. Questions on that? So it's B, C, and D is what I think the best answer is. Okay. I would go with B, C, and D. All right. Questions? Again, I think a couple of those were a bit tougher than, whoever wrote those were a bit unclear on a couple of them. Okay. So I put for myself to remind you on this. Some of these that aren't statistical, we could reword and make them statistical if we ask the question differently, but that's not what we're doing. Okay, so here's another list of questions about students and teachers at a school. So we're looking for which are statistical questions. Okay, so I'm seeing, so circle the ones that are statistical. I see 1, 2, 4 are statistical questions, 2 are not. I think this one's a bit more clear than the other one. Okay. So there's 4 that are statistical, 2 that are not. So circle the 4 that are. Meaning you could get varying answers. Okay. So we're talking about one certain school. Okay. Not a bunch of different schools, just at a particular school. You should be picking 4. Okay. Let's see here. I don't have the names on there, Chloe. Okay. Let's see. 1, 2. Yeah, that's right. There? Nope. Mm-mm. All right. So let's look through these. Again, this is not super hard, but there is a little trickiness to it. Okay. So if you look at B, what school did the students attend? You're at that school. So there is no variation in that data. They all attend that school. That's wrong. Okay. Now, there's one more of these that are wrong. Okay. The one more that it's wrong here is going to be the one that has a certain answer that is a definite answer. Okay. So if I go down the road to Powdersville Middle School and I ask them one of these questions, there's only one answer to that question. The answer is the other one that's not statistical is the number of math teachers at the school. So if I go ask them and they say there's 8 math teachers, that's a fact. Like that is, there's no variation in that data. It doesn't change depending on, like, if the person is right in their answer, then there's no variation in the data because there's only a certain amount of math teachers at the school. Okay. Now, most popular lunch choice. You could say some people like chicken fingers, some people like pizza, and some people like this. So you would get varying answers that you could study. So that is A. A common age for teachers at the school would be like you're gathering, well, some people are like in their 40s and their 50s and their 30s. So you get varying answers on that, and then you can study it. So that's statistical. About how many hours of sleep do students generally get? Some people get 6, 7, 8, 9, 10. So there's varying answers you could get there. And then how do students usually travel from home to school? You got walking, you got biking, you got riding the bus, you got riding the car, right? So that's several different types of answers. So the answer would vary. Okay. Again, this just takes a little bit of practice to get it. That's why we're doing it, because once you get it, it won't be hard. All right. Any questions on that? So B and C have one definite answer. The other ones have answers that vary. Okay. All right. And then should be the last one here. Okay. So question A says over the past 10 years, what is the warmest temperature recorded in Fahrenheit for the month of December in Miami, Florida? Okay. And then the second question is what temperature does water freeze in Miami, Florida? Okay. So what you need to do on this one, all right, is you're saying, is it statistical or not statistical? So write S or N and then put Y. So this one you should be typing a little yes or no and why on here. Okay. Let's take a minute here to put yes and or no and why. I'll give you a hint. One of them is yes, one of them is no. Okay. So one of them is statistical, one is not, and then you need to put why. Maybe about 30 seconds. At least get going on it. Okay. So this person right here, this is correct on B. All right. B is not a statistical question because water freezes at the same temperature everywhere. Okay. So this one is the no. This would be it. So this would be non-statistical because water freezes at 32 degrees Fahrenheit everywhere. All right. Although salt water is different, but regardless, it freezes at the same temperature everywhere. Right. Okay. The answer on A should be something like this. All right. The warmest temperature recorded in degrees Fahrenheit for the month of December in Miami, Florida. That would be yes, that's statistical because you would have 10 different, right, years with varying data by year. Okay. Again, you probably say why this is a standard we need to work on, right? Because you got to learn how to think through and understand these. Okay. Um, so go ahead and finish that last slide up there. All right. And as you're finishing that up, I'll just put in conclusion. So today's practice is going to be statistical and non-statistical questions. I would really urge you, please make sure you listen to, after you've done them and attempted them, watch the video going over the practice just so you hear my explanation. Hearing that repeatedly is going to help it really stick in your mind how to think through them. Okay. And then tomorrow we're going to review GCF and LCM and word problems with those skills. There's videos to watch before you start the practice that you need to watch, all right, in terms of reminding you how I want those skills shown and how to tell which one is which with the word problem. And then there is also the video to watch afterwards to check your work also. Okay, then Friday there's a data and review quiz 1. So the data part, there's not work to be shown. The GCF and LCM questions must have work shown or I'll take points off. And then when I grade that, I'm going to list the grades. I'm going to have the grade recorded one time, but then I will tell you what the grade is on each part of that quiz listed in the comments, because it's two completely different standards that I'm putting under one kind of little quiz. Okay. All right. So that is that. If you finished up, if anybody needs me to go back to a previous slide, just let me know in the chat. All right. Otherwise, I'll see y'all later. What's up, Gray?
Can you just I forgot what slide it was, but it was the one where we had to come up with our own like statistical questions or
Yes.
something like I forgot which slide it